Hi, my name is Josh Stroshine, and this is my video recording for Exploit1 for INFA725. To get started, I'm looking at, I have a Windows XP Home Edition Service Pack 1 target with Surge Mail running, and I've already had the Immunity Debugger detached, so that's all set up. Here's my Backtrack 5 and the script for the IMAP fuzz, largely based out of the book, and then the main areas that I'm going to be tweaking here through this video are going to be the fuzz values themselves. So to start with, excuse me, I've got a fuzz value. I'm going to send 11,000 A records just to see if the application itself is vulnerable. As you can also see here in this next command line, I do have that auxiliary module loaded and ready to go, and the options are available. So I'm going to set those according to the values that I used when I set up installed the service. And then the rhost, which is my for my local network. And then I'm going to just rerun just to make sure it's been built. I can see there that it sent all 11,000, and if I go into my Immunity Debugger, I can see if I follow the address in the stack that everything was overwritten, including the SEH. So the next step now, going back to my actual script, is to figure out where that value is. And obviously with 11,000 A records or A characters, that's going to be pretty hard to figure out. So with this, I'm going to send a unique non-repeating pattern of 11,000 characters and try to identify the location in that string where I overwrote the SEH value. So at this point, I'm going to go ahead and restart. Make sure we're not paused. Appear to be good. And then I'm just going to go, since I changed that script, and I'm going to make sure I saved it, and then rerun. Okay, there we can see unique string, and if I go into Immunity, I can see that the file address into the stack 684E3368. That's the string value that I sent that overwrote the SEH. Now I can go back to Backtrack and use a tool, the Ruby pattern offset, pattern offset. It's a Ruby script, and pass it that string value and then the length of the string that I sent it, and that gives me a value of 10,360. So from this, I know that 361, 2, 3, and 4 are the bytes that I can use to overwrite SEH. So when I go back to my fuzzer, I can now send it 10,360 A values for B characters, and then the rest are C, just to keep that 11,000 length string constant. So what I'm looking for then is an SEH value that has these 4 B characters. So I'll go back to Immunity, go ahead and restart the process, make sure we're not paused, and should be good. And now I'll do a rerun. And if I follow this into the stack, I can see not quite what I was expecting. So I have not, obviously I forgot to save, so just bear with me as I rerun that again and restart my debugger. Give that just a second. I know sometimes on this virtual machine it takes a little bit before it picks up and the process is done running. I think we should be good. Okay, not quite. There it goes. Now we'll rerun, and if I go to follow the address in the stack, I can see there's those 4 B characters that I sent. So I know now I have control of the SEH. The next part of this exploit then is to move into actually writing the exploit. So again, I followed the template from the book and a few examples I found online and set it up. I've got a couple areas that I'm going to step through kind of in the same fashion I did as that last one. I did copy the bad chars and then the return address. This is one of the first things I needed to find before I really ran this, and in order to do that I need to use another tool. This one is part of Metasploit, and minimize that, and it's MSFPE scan. I brought surgemail.exe onto my desktop, and then I ran. What I'm looking for is a pop return, which I found. The book recommends using the last value, and so I didn't experiment too much with that at this point in time. I just went ahead and used that last value, and then using little endian, because it's in reverse order. Then I take this value 7E5178 and I make that as my return. So that way, then when I load this first payload, I'm going to give it a lead with that offset that I found from the fuzzing stage, and then that return address. And I'm going to get that set up, and then I'll step through that. Okay, I've got my exploit loaded. All the options are set, and I have immunity running. So what I'm going to do is I'm going to do our exploit, make sure that module is rebuilt. And make sure that's not paused. Run it again. And okay, so now immunity caught an exception. If I follow that address into the stack, I can see that I got a value there. What I want to do though is I've already got a breakpoint set, so I'm going to shift F9, and what I'm really interested in is the fact that I've got the pop return. So that return address that I wanted is there. As you can see here, it jumps, and then it just continues execution. So the next step, get this restarted. And the next payload I want to try, or will try, is to provide a short jump. So I'm going to save, make sure immunity is running, and exploit. Alright, perfect. Come back to here. Again, it's been caught, an exception's been caught, and I'm going to go ahead and pop return, and there's the jump, and now I'm back into my part of my payload. So the next step, get that restarted. Is to provide that near jump, which is going to bring us to closer to the beginning of that buffer and give us plenty of space to send our shellcode. So what I'll do is I'll go ahead and save that, and make sure we're running here, and then rebuild that module and send it. You can see we caught another exception, and if I step in, there's a jump, and there I'm in my NOP sled. So as you can see from my payload, I did build a NOP sled minus the payload's length, and then there's the near and the short, and then there's the actual, the payload all built together. So at this point, all that's left is I'm going to restart one last time. I'm actually going to detach it, and I've got to set the payload to something useful. So Windows shell, TCP, and then run the exploit again. And then I'm going to pause the video until this actually happens, because this might take a few. Okay, and here we can see that I got my reverse shell, and just to verify that I am on that the host I wanted, I can see the 10.0017 was my target. I hope this covered everything, and I'll get this uploaded tonight.